Hey, in this lecture I want to talk about memory leaks with smart pointers and how to avoid those. For this example I have the entity struct again, and it has a destructor which will print out an appropriate string, so entity destructor invoked. In the main function I have entity pointer, which is an object of type unique pointer, and I pass in entity. Then I do a new entity and I pass in 55 to initialize the integer member, and I simply have this if statement right here to check whether that is null pointer. So if entity pointer is null pointer, I'm going to print this out, otherwise I'm going to print out what the member is. To start off with, let's see a case where we can get a memory leak with the release member function. I have a raw pointer now, a pointer to an entity, and I assign this to that. I do entity pointer dot release. Now this is not a very common statement, you may not even have thought about this, but you have to think about what a function can return. This release function, I'll just do Ctrl-Shift spacebar, and you will see this release function returns a pointer to an entity. The release function, similar to the get member function, is not something that we'll use often. What this is going to do is it's going to return the address of the entity that's on the heap, and we are going to store that in the pointer here, but it's also going to set the managed pointer of entity pointer here now to null pointer. So it's not just going to fetch the address, it's actually going to set the managed pointer to null pointer too. Okay, this is basically what the release function does. It returns the address of the heap object and it's going to set the managed pointer to null pointer. Now what we can do is we can do console output. We use that pointer, that raw pointer, to fetch the member and print that out. And this should now be true. It should print out cout entity pointer to is null pointer. Actually that is just entity pointer, and I'll change the string here. Just to make that a bit more clear, entity pointer managed pointer is null pointer. Couple of things to notice here, it prints out 55 just fine. Then we get entity pointer managed pointer is null pointer as we expect. And because the release function sets the managed pointer of entity pointer to null pointer, what's going to happen? Well, basically the raw pointer now has the responsibility to clean up that heap object. I'll just enter out of here. When the entity pointer goes out of scope again, the pointer that it manages no longer points to that object on the heap. Only this raw pointer now points to that object on the heap. So what we have to do is, we need to deallocate that object on the heap that PTR is pointing at by doing delete PTR, build and run that. And this is what we need. So we print out 55. That entity pointer managed pointer is going to be set to null pointer now. And then entity destructor is invoked. That is the one that was on the heap. It's important that you don't get the reset and the release functions confused. The reset member function will deallocate the object that is on the heap and set the managed pointer to null pointer. Whereas the release member function is not going to deallocate the object on the heap. It is going to return the address of that object on the heap, but is not going to deallocate it, and then it is going to set the pointer that the smart pointer manages to null pointer. Now let's do something else. I'll do the get function in this case. So get does not set the managed pointer to null pointer. What we should get is, this should print out 55, and then in the if else statement, this should also print out 55. Build and run that. This works fine as expected, prints out 55 twice, and because the managed pointer is not set to null pointer, when the smart pointer, the entity pointer, goes out of scope, it will clean up, when otherwise deallocate that object on the heap. Now there is one issue with this. Let's say you do delete pointer down here now. Maybe you can pause the video for a second and think what's going to happen when I build and run this. Alright, well it's going to deallocate that object on the heap right here now, okay? And then when the smart pointer entity pointer goes out of scope, it's also going to try and deallocate that object, but its managed pointer will be dangling and so the program will crash. Let's build and run that. And you can see what I mean, okay? It crashes and I'll abort. But just notice the output here, we get 55 printed out twice, entity destructor invoked, we get the final output statement, cout statement, end of program. Then it's going to try and deallocate that again and it's going to crash. That is why I mentioned you rarely use the get member function. In this next example, I'm still using the entity struct for the destructor printout, and in the main function, I'll declare a raw pointer to an entity. I'll allocate a new entity object on the heap and assign the address of that to the pointer. And remember, with the unique pointer, we can allocate in this way. Now if you think for a second, what happens when we do this sort of expression? What is it going to return? What does this expression return? It returns a address, okay, that we assign to the pointer. You will often hear the term returning a pointer because a pointer stores an address, right? So if we return an address from here, basically we are returning a pointer. And you can see that these are the same thing. So what we can do is, where we construct a unique pointer, we can actually pass in that pointer now. Now the managed pointer of the entity pointer and this pointer right here, the raw pointer, both will point to the object that is allocated on the heap. And of course that can lead to all sorts of issues. But for right now it doesn't make a difference, because if I build and run, the entity destructor gets invoked and we don't have any issues. But of course, as with the previous example, what happens when I do delete pointer now? Once again we will get a crash. That is because we are deallocating the heap object right here in this statement. But again, when the smart pointer, the unique pointer, goes out of scope, it is also going to try and deallocate that object on the heap or call delete on that. Once more, following the statement where the object on the heap is deallocated, the pointer that the unique pointer object manages is going to be dangling, and of course if you call delete on that, you're going to get a crash. So you can say, okay, that's fine, I simply won't call delete on that pointer. But now you can think for a second what's going to happen if I have two of those. So I have two unique pointers, uEntityPointer1 and uEntityPointer2, both of those smart pointers, which I will initialize by passing in that address basically to that object on the heap. And what do you think is going to happen now? Well, when the first smart pointer goes out of scope, it's going to deallocate the object on the heap, right? Then of course the pointer that the uEntityPointer2 manages will be dangling, and as soon as that goes out of scope, again we will get a crash. Build and run. And you see we get a crash. As a summary on the release, reset and get member functions, the release member function is going to relinquish ownership and return a pointer to the object on the heap. The release member function does not reallocate the heap object. Okay, it basically passes off management to another pointer, typically a raw pointer, and it will also set the managed pointer to null pointer. The reset member function, on the other hand, is going to deallocate the heap object and set the managed pointer to null pointer or to the pointer argument. Then we also have the get member function, which is simply going to return the managed pointer, in other words the address, stored in the pointer member that the object manages. Now where is this get member function useful in the first place? Because we are deleting the copy constructor and the assignment operator, so we don't really want to give outside access to the pointer member. Well, it is useful in the case where you manage memory in your own code using smart pointers, but you need to pass the raw pointer to typically older code that does not support smart pointers, typically code written before C++11. Alright, that is going to wrap up this lecture. I'll see you next time.